Greetings and welcome to the Introduction to Astronomy. In this week's Misconception in Astronomy, we are going to talk about orbits, and specifically the orbits of the planets, and find out if they are indeed circular. So, are the orbits of the planets circles? And the quick answer to that is no. But this is what we believed, and in fact most scientists would have thought this until the 1600s. So for most of the time that we tried to understand orbits of the planets, and going back to the teachings of Aristotle and the other Greek astronomers, the idea was that heavens were perfect, and therefore anything that moved within the heavens had to move in the perfect shape, which was a circle. And this caused problems in trying to be able to accurately predict the positions of the planets. So what did we eventually find out? Well, Johannes Kepler in the 1600s, and in fact in 1609, determined that the orbits of the planets are ellipses. And this was based on the observations of a previous astronomer, Tycho Brahe, who had made detailed observations of the planet Mars. And Kepler's study of Mars convinced him that the orbit could not be matched by a circle. So what is an ellipse? Well, an ellipse in a way is a squashed circle, and we can see an example of an ellipse here. An ellipse has two axes. Now in a circle we have a diameter, which doesn't matter where you go in the circle, it's always the diameter. However, in an ellipse, you have a longer axis. In fact, the longest axis is called the major axis, and the minor axis is perpendicular to this, going through the shortest path through the ellipse. And the eccentricity is the key here. The eccentricity really tells us the amount of the deviation from a true circle. So an ellipse with an eccentricity of 0 is a circle. That's what we thought for the longest time, is that all of the planets orbited in circular orbits. An ellipse will have a value between 0 and 1. So it has to be greater than 0, but less than 1. So you could have something like the Earth's eccentricity in its orbit, which is 0.018, or very close to being a circle, but not quite. And you can go up to an ellipse of having 0.999 and continuing on as long as you don't hit 1. Once you hit 1, it is no longer a closed orbit, it becomes a parabola, and that is quite different. Now, how close to a circle are they? Why did it take us so long to realize the true nature of the orbits? Well, the thing is that they are actually very close to being circles. The Earth is 0.018, which is right in between these two, 0.0 and 0.1, and much closer to the 0, which is a circle. Now, I challenge you to kind of look at these and see where along here you can start to see that they are deviating from being a circle. Can you see it at 0.3, or do you have to get out to 0.4 or 0.5? Certainly by the time we get to 0.5, I think it's pretty clear that we do not have a circle there anymore. But it's not easy to tell the difference. In terms of the planets, Mercury fits in here at about a 0.21. So that is the highest deviation of any of the planets in our solar system from being a perfect circle. So it's very hard to see the difference. You're not going to tell that, and that's going to be why it took so long to really realize the true nature of the orbits. If planets had orbited like this with a 0.8 eccentricity, we would have known the planets were elliptical in the first place. Of course, if our Earth had a 0.8 eccentricity, we wouldn't be here, because that would mean we'd go in close to the sun for a very short time, and then we would spend most of our time far away from the sun, and it would be far too cold to be able to support life. So let's go ahead and finish up with our summary, and what we've looked at today was circular orbits, and found that the planets' orbits are circles, not circles, but are ellipses. This was determined by Johannes Kepler in 1609, and we talked about the eccentricity, which tells you the amount of deviation from a true circular orbit. So that concludes this week's misconception on the orbits of the planets being circles. We'll be back again next week for another misconception in astronomy. So until then, have a great day, everyone, and I will see you in class.